saw at that moment. Across the room, the faces of these teenage girls just lit up. I saw passion, amazement, and even some relief as this incredibly technical field suddenly took on a human form. Click, please. This is the story. I want to click back. This is the story I want to share with you today. The deeply human side of artificial intelligence. In fact, I hope to convince you that there's nothing artificial about this at all, especially at this historical moment, as AI is about to transform our world in ways we can barely imagine. Click, please. I've been a researcher for almost 20 years in the field of computer vision and machine learning, a central part of AI technology. By coincidence, my academic journey began with the recreation of the very experiment that inspired both these fields to a large degree. This was the landmark experiment by Hugo and Wiesel in 1959. By putting electrodes in cats' visual cortex and connecting the output to a loudspeaker, then projecting patterns of light on the screen for the cat to see, they could literally hear for the first time the cat's visual perception at work. In this process, they discovered that the brain of cats, as well as other mammals, is organized by neurons that are stacked in a hierarchical fashion, with each layer responding to increasingly more complex visual patterns, starting from simple edges. This groundbreaking work shed first light on how the computational structure of mammal vision, including humans' visual system, works, and were awarded the Nobel Prize for Medicine in 1981. More than 40 years after their work, I had the opportunity to replicate this experiment as a college student intern in a neuroscience lab. No words can describe the sense of magic I felt at the moment when hearing the neurons responding to the patterns of light in the darkness, realizing that this rich and beautiful world we see all began with tiny neurons in our brain that get excited by such simple patterns. So I began to wonder if we can one day build computers that can see like us. Click. It turns out I wasn't the only one asking this question. Hugo and Wiesel's experiment had already inspired pioneering scientists to begin developing computers and robots that can learn to see, a journey that has now lasted for more than 50 years and blossomed into the entire field known as computer vision. By the time I entered my PhD study in 2000, computer vision has grown into a field of thousands of researchers worldwide. But teaching computers to see is easier said than done. A modern camera easily registers millions and millions of color pixels when taking a photo. But that's only a 2D projection of an infinite number of possible 3D scenes. The job of an intelligent visual system is to figure out the meaning and layout of the real 3D scene behind the 2D projection. This is computational computationally and mathematically a daunting task. It's no surprise that it took Mother Nature 540 million years to create our remarkable visual system. To appreciate the incredible capability of human vision, one of the first experiments I conducted as a PhD student was a study of how we perceive with a single glance of the scene. We showed that for a person, a split second is all it takes to understand a staggering amount of information, like objects, people, movements, even social interactions. And we can describe what we see in great details using language. Teaching computers to do the same has become one of the holy grails of the field of computer vision and artificial intelligence. But how do we teach computers to understand all the visual depth of our world? Where do we begin? When I joined the field, computer vision research was still struggling with recognizing simple things like faces and cars. Much of our attention was focusing on designing models to account for the countless number of possible variations and details of everyday objects. While progress was made, the algorithms we developed were far from working. Luckily for me, I arrived at a unique time in history. The internet was exploding in popularity, and that gave researchers across the world more data than ever seen before. This sheer variety and depth of images available online made me think about the constant visual stimulation children experience as they grow. So my students and I began to ask ourselves this question: what if we could use the internet and the data to help our algorithm to explore the world in a similar way? So in 2007, I began a project with my students and collaborators called ImageNet. It had an ambitious, if not ridiculous, goal to organize enough images from the internet to teach computer algorithms that everything in the world, about everything in the world. And I mean everything: dogs, cats, flowers, dolphins, airplanes, bridges, and 22,000 other categories of objects for a total of 15 different photos. It was the largest AI dataset ever publicly released at that time. But here's the really tricky part. In order to accurately teach an algorithm to benchmark its progress, every single image must be labeled correctly. And we needed to sort, clean, and label from a pool of billions of candidate images downloaded from the internet. It took us 3 years, numerous failures, and some desperate moment of scrambling for funding. But thanks to crowdsourcing, we did it with the help of more than almost 50,000 online workers from 167 countries. Yeah, we got a little crazy, but that's the fun of science. So the hard work paid off. That's the stats. So what happened? The hard work paid off. Our field of computer vision started to take advantage of this data set and started to speed up the development of algorithm in a new light. Instead of focusing on hand-tuning machine learning models, we're starting to look at the interplay between data and algorithm. If you look at the challenges that we put together for the world called ImageNet Challenge, our error rate started to steadily decrease every year we held this challenge. And by 2016, the error rate of object recognition start to be as well as humans. And you all know there is an important moment that happened between 2001 and 2012. We began to see the winning algorithm for ImageNet challenge is using an old technology, a classic technology called neural network or deep learning. And that set off the deep learning revolution we see today. So ImageNet, so what happened? Well, ImageNet provided with our computer vision algorithm a wealth of information. And together with modern chips as GPUs and CPUs, we revitalized an old class of algorithm called convolutional neural network, developed or pioneered by computer scientists in the 1970s. You can think of a convolutional neural network as a mimicry of the brain. Its basic unit is a neuron-like unit that takes in inputs and sends out one output. And millions of these neurons or neuron-like units are stacked in a hierarchical fashion to build a final model. And these models are huge. A few years ago, a typical model that is used to win the ImageNet challenge has more than 24 million nodes, 140 million parameters, and 15 billion connections. And today, this number has increased dramatically. So with ImageNet and convolutional neural network, we're able to push forward the research of the holy grail of computer vision, which is recognizing the contents of the scene, such as object recognition. Here is an example of a computer vision algorithm detecting an object in the scene. Here's another example. Here's another example. And here's even a cluttered scene. And then we're not satisfied, because just recognizing objects is not enough. We'd like to also be able to describe the world. So my students and I begin to make more progress in the challenge of, here's another fun way of annotating objects when the computer is not sure what it is. So it cleverly called it an animal instead of a duck. And here's an example of the computer recognizing very detailed objects, such as the make model of cars, better than most humans can do. So not only we're looking at objects, we're not satisfied with just labeling a discrete list of objects. We're starting to connect the human language with the description of the scene. And this is the next wave of the model by captioning images. And this is the recent work we have done for computers to be able to generate human-like sentences to describe a scene. And recently, we have just published a paper that not only generates sentences, but also generate paragraphs. Even though these paragraphs are still not as beautiful as in Shakespeare writing, but it's starting to communicate with humans in ways that I had never dreamed of when I started my PhD study. But while a lot of progress has been made, I do want to remind you that we still have a very long way to go. Today's AI is great at pattern matching in narrow tasks like object recognition, face recognition, and image captioning. But there's so much more to human thoughts and intelligence than simple patterns. This is clear to everyone who has studied cognitive neuroscience or just raised children. Just a few days ago, a few weeks ago, I literally watched my 20-month-old daughter climb out of her escape-proof crib with nothing more than a few minutes of trial and error, completely underestimating I was completely underestimating her learning ability. Don't worry, she's fine. But she's not even 2 years old. But her creativity, improvisation, dexterity is light years ahead of any machines we can build. This is why the next step in AI will have to be inspired by a new level of neuroscience, cognitive, behavioral, and even psychological understanding. Work is already moving in this direction. Research is underway on highly intuitive agents that can communicate and collaborate with humans, such as chatbots that you just see, that can reason their way through naturally phrased questions, or robots that can navigate through crowded space. In short, the future AI will not only be able to do some pattern matching, it has to understand us, interact with us, collaborate with us, even augment us in deeply human way. The research of AI was originally drawn from human inspiration, but the explosion of the progress over the last few years shows us the human dimension of AI is going a lot further than just the inspiration from our brain. AI is no longer just a science for scientists in the laboratories. It has become one of the biggest driving forces of what some call the fourth industrial revolution. It will have a profound impact in how humans live, work, and shape our environment. So what role should such a powerful technology play in our world? Who will benefit from it, and in what ways? It's not enough to just think about the next flashy product. We have to begin considering how people will be affected. I'm happy to say that I'm surrounded by researchers who are trying to do exactly that. My colleagues at Stanford are working on many frontier fields of AI, such as applying machine learning to education, or using satellite imagery to track poverty more precisely, or developing diving robots to explore the deep sea where it's too dangerous for humans to go. And my own students and collaborators and I are also working in health critical situations to use AI to assist families, nurses, practitioners to help people with illness or aging seniors. And at Google and many other labs around the world, research is emerging on issues of fairness in machine learning, or using algorithms to identify bias in everything from legal systems to casting patterns in Hollywood movies. But just like any technology, AI is a tool in the hands of people. In fact, I believe that there is no independent machine values. Machine values will come from human values. It's vital that we recognize this now, as the impact of AI on society is only growing. Without thoughtful guidance, many of its benefits could one day cause unintended harm as well. For instance, while AI is great at analytics, algorithms trained with biased data are more prone to treat underrepresented groups unfairly, regardless of the developer's intention. Or take the case of robots and automation. While they have the great potential to improve productivity and can reduce risk for humans, it's important to consider their potential to disrupt jobs and labor markets. They can even be weaponized to harm people. And while smart algorithms can help summarize information and generate useful reports, for doctors, lawyers, teachers. They can also be misused to disseminate fake news and challenge the foundation of social discourse. These are just a few examples of the daunting question and challenges we face collectively as a society. And I don't pretend I have the answers, but it's clear we're entering an era in which technology should be guided by our values as much as our engineering and scientific ingenuity. Solving technical problems is just the beginning. We may find that the ethical riddles even more challenging. The first step towards building a technology that is benevolent to all people, not just a privileged few, is to understand who is leading the development of this technology. The AI of the future shouldn't just benefit us all, but it needs to reflect us all as well. So how well are we represented in the development of AI today? I'll just be blunt here. Diversity is sorely lacking in the world of computing. That includes AI. The National Science Foundation reported in 2016 that fewer than 30% of computer science majors are women. A similar 2016 study showed that fewer than 15% are left by the time they reach professorship. Similar numbers can be found across Silicon Valley's tech companies. And the statistics for racial minority groups are even worse. If the technology is going to change our lives, our society, and perhaps the entire future of humanity, and I believe it will, then this lack of representation is really a crisis. We can do a lot to address this, and a lot of efforts are already underway. Just like the example I talked about at the beginning of this talk, I co-founded this summer camp called AI for All 3 years ago with my former PhD student, Olga Rusakovsky, now an AI professor at Princeton, with the goal to inspire girls and students around the country, not just to pursue technology jobs, but also to recognize the human impact that AI has on the world. The program was so successful that we decided to expand it to other campuses in North America through collaborations with our AI and CS colleagues around the country. The result is AI for All, a non-profit organization focusing on increasing diversity and inclusion in AI through educational programs. We specifically target high school students of all walks of life, not just girls, but also underrepresented minority in socio-economical classes, in racial groups. AI for All was launched earlier this year, seed funded by Melinda Gates and Jensen and Lori Huang Foundation. From Stanford, AI for All is already starting from Stanford, we are already expanding to other campuses in North America, such as Berkeley, Princeton, Carnegie Mellon University, and Canada's Simon Fraser University. It's my hope that AI for All programs like AI for All will be the first step towards a healthier, more inclusive conversation of who's involved in building the future. No technology is more reflective of its designers than AI. From the architecture of its algorithms to the application of its models. And it's really our responsibility to ensure that everyone plays a role. So, especially in this context, I also want to add, this is a global technology. AI doesn't just belong to Stanford, to Google, to Silicon Valley, or not even to Zhongguancun. AI belongs to the world. And the partnership of leading countries, leading thought leaders across the world is vital for the benevolent development of AI. Of course, there is healthy competition between regions, between companies, between labs, but more importantly, we need to recognize that it is our collective well-being that is being impacted by such a powerful technology. And groups like the emerging economy of China and the emerging power of Chinese culture bears that responsibility just as much as the leaders of Silicon Valley and the rest of the world. So I want to sum it up in this way. We know AI is going to change the world. The real question is, who is going to change AI? And I hope that all of you will participate in this positive change for our world. Thank you.
Thank you, Feifei, for your wonderful presentation. And the newly information just released that Feifei is just now won the award, you know that? It released by Caixin Media, which is also a leading financial media in China, that gave the award to Feifei, the annual Woman of Innovation for her ceaseless striving in advanced technology. Congratulations. And Feifei is supposed to receive the trophy in Beijing, but today, thank you very much for your great effort, for contribution to our event. Thank you again.